Good morning, everyone. My name is Navneet Menon. Today, I'm gonna present my topic threads. First, we will introduce the what is threads and advantages, type of threads, and real life using with examples, some of the images of threads, summary of work carried out, and future scope of threads and conclusion and reference will be included in this PPT. So, first we can check what is thread. A thread is a flow of execution through process code that has its own program counter to keep track of which instruction to execute next. In simple words, a thread shares with its peers threads few information like code segment, data segment, and open files. When one thread alters a code segment, memory item, or other threads see that. In other words, a thread is also called a lightweight process. Threads provide a way to improve applications performance through parallelization, and threads represents a software approach to reduce the overhead. Thread is equivalent to a classical process. Each thread belongs to exactly the one process. Now we can check into some advantages of threads. Threads minimize the context switching time. Next, use of threads provides concurrency with a process. Efficient communication. It is more economical to create and context switch threads. Threads allow utilization of multiprocess architectures to a greater scale and efficiency. These are some of the advantages for threads. Now we can check some of the types of threads. User level threads. In simple words, level threads are user managed threads. In this case, the thread managed kernel is not aware of the existence of threads. The threads library contains code of creating and destroying threads. Maybe like passing messages and data between threads, or for scheduling thread, or execution and saving, restoring. Such type of threads are used in user level threads. Its advantages are like thread switching does not require kernel mode privileges, and it's also threads are faster to create and manage in operating system managed threads and acting as a kernel and operating system core. In this case, thread management is done by the kernel code in the application area. Your kernel threads are supported directly by the operating system. Multi-thread or in the threads with an application are supported within a single process. Next, like real life usage. The next example for the threads are games. Games are very good examples for threading. You can use multiple objects in a game like cars, motorbikes, animals, people, etc. while you playing. All those objects are like threads that run your game application. And another example for real life use examples are like browser redirecting to web page. It's mentioned that when you are in a web page, when you click on a button, it will be redirect to another web page, and the rest of the content will be downloading or loading into your web browser. That is one of the thread. You can see it in an image. Now you can see three screenshots of the different models of threads. These are the some of the different models: many to many model, many to one model, one to one model. In many to many model, you can see itself in the image that many to many model multiplexes any number of user threads. In simple words, in this following diagram, you can see that threading model where 6 user level threads are multiplexing with 6 level threads. In this model, developers can create as many use threads as necessary, and corresponding kernel threads can run in parallel. Next one is many to model. Many to model maps many user level threads. We have mentioned it before. The user level threads is managed by the user to one kernel thread. Thread management is done in user space by the thread or library, where thread makes a blocking system, or like block it. Only one thread can be blocked in the kernel at a time. Next one is one-to-one model. There is one-to-one model relationship of users are thread kernel level thread and both user level thread. This model provides more currency to the many to one model. It also allows another thread to run when a thread makes a blocking system call. Next. In this image, you can clearly see how the program works. Initiate includes the process 1, process 2 in the threads, and context switch at last will schedule and execute to the CPU. These are some of the summaries of work carried out by the threads. It can literature is analyzed, and another one is relevant functions below programs have been developed using the threads. Resource sharing. It's one of the main important points within a process. A resource such as code, data, and files can be shared through all threads. Another one is communication. In communication, it is actually simplified across numerous threads since they share a common address space between all. Also special communication approach between two processes. And next one is increased system throughput. When a process is separated into several threads, each thread function is treated as a single task. This is actually means by the because it will also increase the system throughput. Now the future advantages and the future scope and the future developments of the threads. There are two ways of creating threads in the future. One is extending the thread class and other by creating a thread with a runnable. However, one feature lacking its runnable in that cannot be thread return result will be terminates. So one thread can be used anytime. And next in Java, every thread corresponds to one operating system thread. If we create multiple threads to improve multitasking, it would be very heavy task as creating a thread in itself is an expensive task. This is the world right now working on it. Next. So next we will conclude this whatever we have gone through this PPT. We have analyzed how multitasking and how the threads and different types of threads and its models, how it works towards the critical shortage of time but an efficient program. And however, the power of the thread programming provides should be used with care. And also the same is true for lacking shared resources between threads in the same process and a different process too. You can see within that example of that photo how the different threads is working within the same process. These are some of the references for the we will get in the Wikipedia. For this, I am concluding my presentation. Thank you.